Chemistry lessons. How to determine an empirical formula and a molecular formula of a compound. First, the definitions. An empirical formula of a compound is a representation of the simplest whole number ratio of the moles between the elements in this compound. The molecular formula is the representation of the actual number of moles in the compound. Okay, we're going to go through a step-by-step deal to show you here, but let me give you something. Let's say that we're taking a look at, we'll say sugar. Okay, so we'll just say basic sucrose. No, let's say something simpler. I'm sorry. We're going to say hydrogen peroxide. So hydrogen peroxide here is H2O2. That's what the chemical formula for hydrogen peroxide. So that is the molecular formula for hydrogen peroxide, H2O2. But the empirical formula, as it shows, is the simplest whole number ratio of those moles. Well, I can see here that that's a 2 and that's a 2, so the empirical formula of this would just be HO. Now let's take a look at it in depth and the problem and how you'd actually have to try to solve it. They give us a problem here. It says we got a molecule with a molecular weight of 180.18 grams per mole. Okay, so that's given. And it is analyzed and is found to have 40% carbon, 6.72% hydrogen, and 53.28% oxygen. Now, it wouldn't matter if they had these in percentages or grams. The way you do the problem is the same exact way. Step one, we're going to turn these percentages or grams. If they gave you the problem in grams, it'd be the same thing, so or grams, into moles. Okay? So we're going to turn this into moles. So I take 40% carbon, and I've got 6.72% hydrogen, and I've got 53.28% oxygen. So I write my numbers down, and I got to turn them into moles. Well, finding moles is simple. I go to the periodic table, and I see that the moles amount of grams in 1 mole of carbon is 12 grams per mole. Okay, I see that hydrogen here is 1. So I take 1 gram per mole, and oxygen here is 16 grams per mole. So I divide and use my math, and whether this was 40 grams or 40%, it makes no difference because percent is all part of 1, correct? So it makes no difference. It all adds up to, 1 or 100. So I got 40% divided by 12, and that gives me 3.33, okay, moles. All right, now over here I got 6.72 divided by 1, of course, would be 6.72, okay, moles. And down here I've got 53.28 divided by 16, which is going to give me 3.33 moles here. So step one, I have just done what we're supposed to do. Take what they give us, either in grams or percentage, and turn it into moles. Now let's go on to step two. Amount of moles, which I showed back up here at the top. Now what I want to do is I want to then be able to look at those and find which element has the smallest number of moles. Here, both carbon and oxygen have the same number, but if one of them was smaller, that would be the number I'd use. Since they're both identical in the smallest, that's what we're going to have to do. So once again, we'd write down what we have. Carbon's 3.33. Hydrogen is 6.72. Oxygen is 3.33. And I'm going to divide them by the number that is the smallest, whereas in this case, as you can see, it is 3.33. And when we divide this, we get 1, we get 2.01, and we get 1 here. So what this is it's showing me, okay, that is the amount of the whole number of moles in that percentage. Now, if these numbers were bigger than this right here, see, 0.01 is so small I can just eliminate that. And I've got my whole number ratios here. The rule usually is if you're somewhere around, 0.2 to 0, okay, you can round. Or if you're at 0.7 all the way up to the full number, you can round. But in this area here, if this number was, 2.3, 2.4, 2.5, 2.6, anywhere in through there, then I'm going to have to divide each one of those once again by a number, or multiply it, it makes no difference, by a number that's going to make these as close to a whole number as possible so I get back within my rounding rule, okay? But right now we're at C1H2O1, okay? Now that basically, step 3. As I told you before, we can get rid of this, so this is my empirical formula. I've got C1H2O1, and remember, when we're doing this, we do not put ones in there type deal. So my empirical formula is CH2O, okay? And that's how we would take that, be it in grams or percentages, and create the empirical formula for this particular compound. Now the next step is molecular formula. And if we review back with the amount of mass we had, it said that it knew that this compound's molecular formula was 180.18 grams per mole. That was given, and we just calculated that our empirical formula was CH2O. So step 1, I have to determine what is the mass per mole of that empirical formula. Well, we know that carbon weighs 12 grams per mole, and I have one of them. So that's 12 grams. I know that hydrogen weighs 1 gram per mole, and I have 2 of them. So that's going to be 2 grams. And I know that oxygen is 16 grams per mole, and I have 1 of them. So that's going to be 16 grams. If I add this all up, 12 plus 2 is 14, plus 16 is going to be 30 grams per mole. So I know that my empirical formula is 30 grams per mole. So the next step is we're going to have to find this ratio between the molecular formula and the empirical formula. So my molecular formula, if you remember right, said it weighed 180.18 grams per mole. And we know that my empirical formula was 30 grams per mole. So if we take 30 and divide it into 180 right here, we get 6. That is the ratio of these elements to each other, okay? So the empirical formula was the simplest number reduced down. The molecular formula is the amount that's actually there and how much it weighs. So then to determine my molecular formula, I would end up wanting to say I've got my empirical formula, CH2O, which then I need to multiply by the ratio of 6, which is going to give me C6H12O6. And that is my molecular formula, which just also happens to be glucose. What I want you to do is to review this. Go back over it as many times as you possibly have to until you think you got it mastered. Remember, it doesn't matter if they give it to you in percentages or grams, you do the same step-by-step process all the way through. If you have any questions, please bring them to class so we can get them cleared up. No misconceptions. Make sure you get this down. Remember, as always, chemists try, never, never, never give up, and stay gritty.